Okay, today we're starting something new. We're going to be using some of these fundamental identities that we have talked some about in our previous classes today. So we're going to revert back to our sheet here, okay? And we're going to look at some of these identities. We have put them on the board before, but we will put them on the board again. We first start off by talking about the reciprocal identities, okay? Reciprocal identities. Reciprocal identities. Remember, sine u is 1 over cosecant u. Cosecant u is 1 over sine u. Cosine u is 1 over secant u. Secant u is 1 over cosine u. Tangent u is 1 over cotangent u, and cotangent u is 1 over tangent u, okay? We've talked about these reciprocal identities before, and today we're going to be using them to solve some problems. We also have the quotient identities. That says tangent u is sine u over cosine u, and cotangent u is cosine u over sine u. Okay? We talked about these before. We talked about the Pythagorean identities, I think. The first one involves cosine and sine. Sine squared u plus cosine squared u equals 1. 1 plus tangent squared u equals secant squared u. And 1 plus cotangent squared u is cosecant squared u. The cofunction identities. Sine of pi over 2 minus u is cosine u. Tangent pi over 2, remember pi over 2 is 90 degrees, is cotangent u. And secant pi over 2 minus u is cosecant u. Cosine of pi over 2 minus u is sine u. Cotangent pi over 2 minus u is tangent u. And cosecant pi over 2 minus u is secant u. Okay? We talked about those cofunction identities. And I think we may have touched upon even and odd functions. Some of these trigonometric functions are even and some are odd. So let's look at even and odd identities. So here, sine of negative u is negative sine u. That's an odd function. Putting in negative u makes the whole thing negative. So its associated reciprocal function is also odd. Cosine of negative u is cosine u. Putting in negative u gives us the cosine back. It is even. And its associated reciprocal function is also even. Tangent is an odd function. Tangent of negative u equals negative tangent u. And cotangent. Cotangent of negative u is negative cotangent u. So these are the identities that we have probably discussed in most of them, but we want to present them again today. Today will be kind of an extension of things that we did a few classes ago. We're going to be, if given certain information about functions, find the other 5 functions, where we may have to use some of these identities. We're going to start off with an example like that. And then we're going to use identities to help us simplify some expressions, okay? So, let's look at some examples. Next couple examples, we want to use the given values to evaluate, and this is if it's possible, the remaining trig functions. So why is that if possible there? Because we know some trigonometric functions are not defined. Like, you know, tangent is not defined when what cosine u is 0. So if possible. So our first example. Suppose we are given that cosecant theta is 5/3 and tangent theta is 3/4. Now, how are we going to use this information to find the other 4 trigonometric functions? Okay? Well, we can find the reciprocal function of cosecant. Sine theta is the reciprocal of cosecant, so that's 3/5. Cotangent theta is the reciprocal of tangent, which is 4/3. Okay? So I have I have cosecant, tangent, that's given. From there I can find my reciprocal function, sine and cotangent. So now I need to find what? Cosine and secant. How can I find cosine and secant? Pythagorean theorem. We look back to our page here, or on the board, and we can see that by these Pythagorean identities, here, if I know tangent, then what? I can find secant. Okay?
Could you just draw the triangle out because it's got each one of the measurements on it? Like cosecant, so the hypotenuse over the opposite. And then tangent.
You could do that. You could do that, but they want us to use these identities to do that. Okay? We're using the identities. But you can't do that. So he had a good start. He said, hey, if I know tangent, I can find secant. So what is secant? Secant squared theta is 1 plus tangent squared theta. So I have 1 plus tangent squared is what? 9/16, right? And 1, which is what? 16/16 plus 9/16 is 25/16, which makes secant theta plus or minus the square root of this, 5/4. Well, how do I know whether to take the positive or the negative? How do I know? We can go ahead and say that cosine theta will be plus or minus its reciprocal function. Cosine, if sine or if tangent is positive, okay, tangent is positive, cosecant is positive, means sine is positive. So Sine positive, tangent positive means cosine is positive. We have to think about these positive and negatives. So here, this is going to be positive 4/5. And it's because sine and tangent are both positive. They're both positive. And because cosine is positive, then that means its reciprocal function will also be what? Positive. Okay? So we have a lot of positive, negative stuff going on here. So we found our other functions: sine, cotangent, secant, and cosine. Any questions?
What if one of them had been negative? Like, which one would it take to be negative to make one of those negative?
Okay. Tangent. If we look at tangent, if tangent is positive, that means either both sine and cosine are positive or both are negative, right? Because tangent is sine over cosine. But because cosecant was positive, that meant sine was positive, which means that both sine and cosine had to have been positive. If this had been positive and this had been negative, then that meant sine would have been negative, and that means that cosine would have been negative. If this had been negative, then we would have to see, well, which is negative, sine or cosine? It would depend on this cosecant, right? If cosecant were negative, that means sine would be negative, cosine would be positive. But if this were negative and cosecant were positive, then that means sine is positive and cosine is negative. So it's just, working with the positive and negative rules and dealing with division. Does that make sense? Are there any other questions? Okay. Okay, suppose we're given that tangent of theta is undefined and sine theta is greater than 0. Suppose we're given that information. Now, what does it mean for tangent theta to be undefined? Tangent theta is sine theta over cosine theta. And in order for this to be undefined, this means that cosine theta is what? 0. Okay? It means that that denominator is 0. Question? So if cosine is 0, then secant would be what? Reciprocal. 0 is the same as 0 over 1. It'll be 1 over 0. So this is what? Undefined. Okay? If cosine is 0, then its reciprocal function is undefined. So we found cosine and secant undefined. What's next? We need to find what? Sine. Knowing cosine, we can find sine by what identity? What identity can we use to relate sine and cosine? No? Sine and cosine? Okay, but the Pythagorean identity that says sine squared theta plus cosine squared theta equals 1. I know that cosine squared theta is 0, which means sine squared theta equals 1. So sine theta is plus or minus the square root of 1, which is 1. But they gave us that sine theta was what? Greater than 0, which means that sine theta is positive 1. Right? You have to use what's given. We got down to here, okay. Sine is either plus or minus 1, but a condition, one of the conditions, sine theta was greater than 0, so it's a positive number. So I know cosine, I know tangent's undefined, I know secant, I know sine. I can find cosecant because cosecant theta is what? The reciprocal of sine, which is also 1. And now I need to find cotangent. Cotangent theta is what? Cosine over sine, which is just 0. Okay? Cosine over sine. So you see that we're just using all of these identities. We're using a vast majority of these identities.
I have a question.
Mm-hmm.
Why did they make it a field if all you have to do is draw a triangle? I mean, that seems easier just to draw a triangle.
Well, here you can draw a triangle. There you could have. They want to get you familiar with using these identities because we're about to go to some problems now. We want to simplify some identities as far as we can go with them, you know. And as far as you can go, I guess that means different things for different people because in some of the directions in some texts they'll say to use fundamental identities to simplify, and there is more than one correct answer, okay? Because it depends on really how you look at a problem, you know. But no, you can't use a triangle for all these problems. So let's use some of these fundamental identities to simplify. Some of these expressions. And again, there is more than one answer. Suppose we're given that secant squared x times 1 minus sine squared x. And we want to see if we can simplify this. Now, whenever you see a 1 in a sine squared or a 1 in a cosine squared, you want to think about the Pythagorean identity, right? Because we have sine squared u plus cosine squared u equals 1, then that means that what? 1 minus sine squared x is going to be what? Cosine squared x by the Pythagorean identity. That's a form of it. Let's look at this. Sine squared x plus cosine squared x equals 1. If I subtract sine squared x from both sides, I have 1 minus sine squared x. And I can replace it here with my cosine squared x. Okay? Can I simplify this a little bit? Secant is 1 over cosine. So secant squared is 1 over cosine squared x times cosine squared x. What is this? 1. It simplifies down to 1. So you start with an expression, okay? And they want you to get, or to simplify. Some of these are very easy to simplify. Some you have to use little tricks to simplify. Example of something that's kind of simple, tangent squared theta divided by secant squared theta. Okay? Now, tangent squared theta, secant squared theta. I can change tangents to secants. Tangent squares to secant squares. Because I have another fundamental identity, one of Pythagorean identities, that says what about tangent and secant? 1 plus tangent squared x equals secant squared x, right? Which means that, hey, I can get some secants up here and just deal with secants. So this means that tangent squared x is secant squared x minus 1, right? So let me replace that numerator with secant squared x minus 1, or this is theta, I'm sorry, theta, over secant squared theta. We have to break them up and then we can cancel, okay? Remember, we can break up a single fraction into two fractions, can we not? We can break this up as secant squared theta over secant squared theta minus 1 over secant squared theta. We have a single quantity in this denominator, and we can break up that numerator. So secant squared theta divided by secant squared theta leaves what? 1. And what is 1 over secant squared theta? What's 1 over secant? What's 1 over secant? Cosine. So that's cosine squared. And what's, let's say, 1 minus cosine theta, squared theta? It's another form of this one where we now solve each side for what? Sine. 1 minus cosine squared theta is what? Sine squared theta. So, what does this mean? We're going to have to become familiar. Even though you're going to be given that sheet, you still need to become familiar with these identities.
So the answer to tangent squared theta over secant squared theta is sine squared theta.
Yes. And there may be other ways that you can do the problem. In fact, I'm looking at a way now that, yes, it is a simpler way. You know, it depends on what you think about when you first look at the problem. There is a simpler way to do the problem. Now, it just came to me now. Because we can change tangent to what? Sine over cosine and secant to cosine and have it. You know, so we could have done all this in 2 steps. So there is more than one way to start the problem.
But regardless of how you do it, you'll come up with sine.
You should get the sine squared theta, yeah. Yeah. As I said, as I'm standing up here now, I'm thinking of other ways that I could have done the problem when I was doing my notes yesterday. So, yes, there's more than one way to start. There's more than one correct answer to the problem, you know. So it all depends on how you view the problem when you first look at it as to how you'll start. Let's look at another one. Cosecant phi times tangent phi plus secant phi. Now what is this going to give us? Well, what is cosecant? 1 over sine. What is tangent? Sine over cosine. So I can cancel out that sine, right? And I'm left with 1 over cosine plus secant phi. Can I write 1 over cosine as something else? Secant. 1 over cosine is secant. So I have secant phi plus secant phi, which is what? Huh? No, this is phi. This is theta. With the little... Yep. Huh? What, phi? It's another Greek letter. Remember, we use Greek letters to denote. We can't use Greek letters to denote angles.
just pick that, use random, I mean, you could have used theta on that too, couldn't
You could have, yeah. The problem that I picked this from, it just came out with 5. Have you ever heard of the Greek alphabet? Alpha, beta, gamma, delta, all those. Phi is in there. It's one of the Greek letters. And I can't really do the Greek letters unless I sing them to you, and you don't want me to sing them to you. Nah, you don't want me to sing them to you. Huh? You do? Okay, I'll sing them and write them, and I'll tell you what they are, but I'm not going to sing them on tape. Well, that's the only way I can remember them is to sing them. Okay? There's a song, but I'm not going to sing the song. Okay, let's move on. I'll write you out the Greek alphabet and I'll run it off and bring it to you. Okay, next we want to factor the expression and use identities to simplify. Okay? So, we have to remember some of our factoring techniques. Suppose we have sine squared x times cosecant squared x minus sine squared x. How can I factor this? I can bring out a greatest common factor of what? Sine what? Sine squared x. So, when I bring out that greatest common factor, I now need to divide. Sine squared x times cosecant squared x divided by sine squared x just leaves to what? Cosecant squared x. Sine squared x divided by sine squared x leaves that 1. Factoring. For example, suppose, let me use some something else here. Suppose we have 7x minus x. What do? We bring out the x. X goes here 7 times. There 1. Well, that's not a good example because you could have combined those. But we're bringing out the greatest common factor. They both have sine squared x in common. Do we remember that? I just taught this morning, too. Trigonometric form. But you can think about it in algebraic form. So, whenever we see these cosecant squares and a 1, or sine squared and a 1, or tangent squared and a 1, that's an indication that we may need to use what? One of the Pythagorean identities. Right? So what Pythagorean identity do we have dealing with cosecant squared x? We have that, what? 1 plus cotangent squared u is cosecant squared u. Right? 1 plus cotangent squared u is cosecant squared u. Which means that if I subtract 1 from both sides, then cosecant squared u minus 1 is what? Cotangent. And now I can simplify this a little bit. Because what is cotangent? Quotient identity, what's cotangent? Cosine. And here we're dealing with squares over sine squared. So that cancels, and I'm left with what? Cosine squared x.
You could go on and on and on with that. Like, can't cosine squared x or something? How do you know that that's your final answer?
Well, it says that your answers may vary. But you want to get to, we don't want to change this back to a fraction. If you get it in somewhere where it's not a fraction and it's a single term like this, then you're probably there. We don't want to say that this is 1 over secant.
I don't like that you can have 2 different answers. I like knowing my answer is right, not knowing that. Because I could be doing it wrong and get a different, I don't know.
That is true.
That confuses me.
That's true. But I don't know what to tell you on that one. because answers will vary. They will vary. Okay. Another example. Cosine squared x minus 4 over cosine x minus 2. Factoring now. We have to be in that mode of factoring. Can we factor that numerator? What is it? Difference of 2 squares? Right? Isn't there a difference of 2 squares? Cosine squared is a perfect square and 4 is a perfect square. So this factors to cosine x minus 2, cosine x plus 2. Oh, y'all are very quiet. Factoring, y'all.
If you don't know, if the answer varies, how do you know that we have the correct answer? You just look at our steps, or how can
I'm going to look at what you do.
to determine whether it's right or wrong?
But if this says you need to factor, then you need to at least start off factoring. There's going to be something that can factor. This is as far as we can go here. Another factoring problem. Suppose we have cosine to the 4th power of x minus 2 cosine squared x plus 1. And this thing is factorable. Would it help you if we substituted cosine with like u or something? Would that help?
No.
No, it confuse you more? You can tell me the answer. What is it? Oh, did I put you on the spot?
Cosine squared x and both sides.
Uh-huh.
A minus and a minus. 1 and 1.
Okay. That's how you factor it. Remember, this is the same as a 4th power here and the 2nd power there can be reduced to a what? A trinomial in which something squared. But if you look at 1, what two numbers give me product 1, sum negative 2? Negative 1, negative 1. Y'all remember that? All right. So what's cosine squared x minus 1? What is that? Whenever you see a squared and a 1, you may want to think Pythagorean identity. Sine squared. So this is sine squared x times what? Which is what? Sine to the 4th power of x. Right? Is this better than the last chapter?
I just never get a factor.
Oh, then it's gonna tear you up. You have to factor. You have to factor. I guess, you know, if you don't rarely factor all the time, once you get to calculus, there will be some factoring, but it'll be a whole bunch of other stuff that's more important. But factoring is important because if you can't factor, then you can't get to the right expression that you need to have.
I took a lot of algebra. Factoring is like that.
I know it. Factoring is like that for me, too, because I have 4 Math 100 classes this semester, and I just taught factoring in every one of them last week, this week, so it's fresh with me right now. Oh, let's look at this one. See if we know how to factor this one. Can't you tell? I've done this 4 times this week. How we factor something like this? 4 or more terms indicate what? You may want to do what? Group. 4 or more terms indicate you might want to factor by grouping. So you group the first 2, the second 2. What can I bring out from the first 2?
Secant squared x.
Secant squared x. So I'm left with secant x minus what?
1.
And I want this to match there, so I need to bring out a what? Negative 1. Y'all remember? So this is secant x minus 1. So now I have a greatest common factor of what?
Secant squared minus 1. Or secant x minus 1.
Secant x minus 1. And what am I left with?
Secant squared minus 1.
Pythagorean identity, what is that? Anybody know what that is? What is secant squared x minus 1?
I don't see it on here.
Look at 1 plus tangent squared u equals secant u. So this is what? Tangent squared x. And this is as far as you can go there. You don't want to go any further. But you do, I mean, if you get to this point, I would take some off because this is a fundamental identity. Okay? If you get to this point, you're okay, you know.
Where is that on there? I don't see where that's coming from.
Pythagorean identity here. 1 plus tangent u equals secant u.
Where is it? Let's see where that matches.
1 plus tangent squared u equals secant squared u.
Okay.
So if I subtract 1 from both sides, then tangent squared u is secant squared u minus 1.
Where's our secret? Oh, there's secret squared.
Mm-hmm.
Okay. And then the other part you just leave there.
Mhm.
Okay. I see.
Because this is just plain old secant to the first power. Secant squared, the squares and the ones you can kind of relate to a Pythagorean identity. Okay. Another example. Let's multiply and use identities to simplify. This next example, we have cotangent x plus cosecant x times cotangent x minus cosecant x. And our directions say, let's multiply, let's use identity to simplify. So we multiply using 4, we get cotangent squared, we get a negative cotangent cosecant, a positive cotangent cosecant, that what? Cancels. And we're left with negative cosecant squared x.
So would it be x squared?
And what is this, huh?
I'm guessing you don't multiply the x's together.
No, just the functions, just the functions. So it's cotangent times cotangent, the inner and outer cancel.
That would end up squaring the x.
No, just the function, just the function. And we'll talk about what to do with those x's inside in a couple of days, in a couple of class meetings. So, how can I simplify this sum? Well, I can get everything in terms of cosecant. What do I know about cotangent and cosecant? I know that 1 plus cotangent squared u is cosecant squared u. So cotangent squared u is cosecant squared u minus 1. So I can put that here. Cosecant squared x minus 1 minus cosecant squared x. And all that simplifies down to what? Negative 1. Because cosecant squared x minus cosecant squared x is 0. Yeah, it's all making sense today. Let's look at another one. We want to add or subtract and use the identity to simplify. Now, this is something that you will use a lot in calculus. This one and then some of the next part, and the next example too, you'll use these little things. Sometimes you may have to combine these by finding a common denominator. What's our common denominator? Secant x plus 1 times what? Secant x minus 1, right? So if we look from here to there, we have a secant x minus 1 that we don't have here. So we multiply that numerator by secant x minus 1. Here, we have a secant x plus 1 that we don't have here. So we multiply that numerator of 1 by secant x plus 1. Y'all remember that finding common denominator stuff? So what do we have here? We have secant x plus 1 times secant x minus 1. We have secant x minus 1. We distribute the negative to get minus secant x minus 1. Right? Remember when you were subtracting, distribute that negative. Secant x minus secant x is what? 0. Negative 1 minus 1 is negative 2 over our secant. We have secant x plus 1 and secant x minus 1. If we multiply that out, what happens? We get secant squared x minus secant x plus secant x. Remember, inner and outer will cancel here. Minus 1. All right, y'all, we have a what? A Pythagorean theorem. Whenever you see something squared and a 1, you need to check whether to see if it's a Pythagorean Pythagorean identity. And it is. And what is secant squared x minus 1? Tangent squared. But I don't want to leave that in the denominator because I can get it to the numerator easily by saying what? Cotangent, reciprocal identity. Negative 2 cotangent squared x. You can't leave it where? I probably would allow you to. Because there are so many different answers, I will be flexible. I would be flexible. All right. Next example. Let's rewrite so that the expression is not in fractional form. All right, let's think about this for a minute. How am I going to write this so that I don't have a fraction? I have a cosecant x plus 1 in the denominator. If I had a cosecant squared x and a 1 down there, I could do some things, couldn't I? How can I get a cosecant squared x down there and a 1? She whispered, multiply both sides, or both numerator and denominator by cosecant x minus 1. She whispered that. But that's correct. That's correct. And this is a little trick that you're going to have to use in calculus a lot. Okay? Is to multiply this by the expression in the denominator, but change the sign. Remember, whatever you do to the denominator, you must also do to what? The numerator. Because what happens down here? We get cosecant squared x. Remember, when you have this plus and this minus, the inner and outer terms cancel out. Cosecant squared x minus 1 down there. When you multiply this out using 4, you get cosecant squared x minus cosecant x plus cosecant x. The inner and outer cancel. And then you multiply the last. 1 times negative 1 is negative 1. Huh? Oh. Thank you. CSC, cosecant. So I still have my tangent squared x times my what? Cosecant x minus 1.
But you're still left with something in the denominator.
Huh?
You're still left with something in the denominator.
But what is this something with the Pythagorean identity? What is that something by a Pythagorean identity? It's cotangent squared. Now I have a tangent and I have a cotangent, and I can break this up. I can say that this is tangent x squared x over cotangent squared x times what? Cosecant x minus 1 over 1. I can break it up that way, can I not? I can. And I can work with this. I can simplify this tangent squared and cotangent squared. What is that? Tangent squared x. Cotangent is 1 over tangent. So what happens when I have a fraction in the denominator? Reciprocal. And this becomes tangent what? To the 4th power x times cosecant x minus 1. Remember, when I have a fraction in the denominator, I take the reciprocal and multiply. And that's as far as we want to get it there. And this looks like 4x. This should be a 4th power. Okay, I think we're going to stop here today. Any questions about anything we've done? We're going to revisit some similar things on next class along with some new things. So, any questions about anything that we've done today? All right, if there are no questions, this will end our class today.